Yeah, I think if you show them that it would be
Prove
beneficial
them.
for Lithuania and your university,
University.
you will be able to open it.
Yeah, okay.
Yeah, but you have to prepare for that and to do a research to prove it that it is.
But you're
it
not
will be.
independent.
No, not really.
Okay.
So moving on to my internship task, so my main goal is to create a social media classifier which could determine if post is negative or positive, and in order to achieve that I had to do several tasks. So the first one is data cleaning. I have to remove unnecessary information from my data for model to accurately find relationships. Second step was exploratory data analysis. It is important to visualize what my data shows to ensure that my data cleaning went pretty well. And lastly, I created a classifier using mathematical methods. So I gathered data from Twitter's social media. My data consists of 800,000 rows. You can see them here. The first column is target, which contains two values. 0 is for the negative data, and 4 is for the positive data. The second column is date for the user and for text. I think I know what they represent.
Maybe you may also, did you say about which library did you use to collect data, or you used Twitter?
Oh, I took that data from the internet. It was collected
directly?
already.
Ah, okay.
It was collected already. I
Alright.
found a big data set, and
Okay, did you pay for it?
No, it was free.
Okay.
Yeah. So about data cleaning, I was working mostly with those two columns, text and target. They are the most important for me. So here's the original text, and here you can see when it is cleaned. So if you had a task right now to find 5 differences, I think that wouldn't be very hard. You can see that unnecessary information like mentions are removed, some words are corrected, and there's a lot of cleaning.
Yeah.
There's like 300 code lines only for the cleaning, so this is the most important, I think, and the hardest task was for me. And
Okay.
as of today, it is not perfect.
Which library did you use to clean?
I used
You
regex. I used analytics library in rep library. I don't know.
Okay.
Yes, I used regex. I used lemmatization also.
Yeah, okay.
And
Instead of stemming,
Yes, yes.
you know the difference?
I had tried both of them, but
Both of them,
lemmatization
what
was
specialist
I liked it more.
Yeah.
And I tried text block correct function,
Text
but
block,
it
okay.
worked very bad on my data, so
Yeah.
I deleted it. Yeah, I did a lot of experiments, but
Okay.
I will not talk all about them because it will take a lot of time, and
Yeah,
just to save time, I will just show you a little of my data cleaning and EDA. So moving on to the exploratory data analysis, here is the most popular words that occur in my data set. As you can see, good is the most popular one. Also, stop words like I, to, and the are removed from here because they would be all over here, and they are unnecessary. Yeah? I do not determine it is positive or negative. So good appear in the both data sets, but mostly in the positive one. That's kind of logical. Only for the positive data we have words like love, thank, great, night, new. Of course, night, I don't know, only by itself it is not a positive word, but words like love, thank will give the biggest impact on determining like if it is a positive text. And only for the negative data we have words like sad, bad, need, wish. So only from this visualization I can say that data cleaning is kind of okay, but after we dive a little bit deeper, and here we can see negative data trigrams. So the most popular trigram is hope feels soon. Probably hope feels soon good. Yes, I'm feeling right now bad, so also rain away, let you hope, sad, John Kate, and after analyzing all the trigrams, you could see that the majority of them are negative, and positive data trigrams is MTV Movie Award, let you hope also. This was the one like in the negative data set. Because he is in the positive in the negative data sets, the impact of him to classify will be not high, because he appears in the both data sets. And of course, after analyzing all the trigrams, you could see that the majority of them are really positive, so it will help me to make my model correct decisions. And moving on to the classification algorithm, do not be scared, we do not dive deep in those formulas, but I have chosen to analyze three.
Term frequency, inverse document frequency, and
Yes, I have used that.
Okay.
Yes.
Processing techniques.
Yes.
And
So
you choose the
yeah, I've chosen
algorithms,
to analyze three classification models. So the first
Okay.
one is naive bias, which is a probabilistic machine learning algorithm which uses bias theorem. I know maybe some of you are familiar with this formula, maybe no. The second one is logistical regression, which is a statistical method that models the relationship between two or more independent variables by fitting logistic function. And the third one is support vector machine classifier, which finds the optimal hyperplane in high dimensional feature space, which separates the classes.
Okay.
So the best result so far is naive bias with accuracy of 77%. That means if we have like 100 posts, 77 of them will be classified correctly, and 32 of them most likely will be misclassified. I think this score is not really high, but I think because the English language has very loud.
You train and you do test.
Yes.
You
Yes.
divide it, and did you use cross validation?
Yes.
Yes. Okay.
Yes, I will not be talking about
Maybe
them.
yeah. For future, you can add all those details also.
Yeah, I
in your
thought
presentation.
that you
Yeah.
wouldn't be interested in that in them, so
okay.
I skipped that part to save time and just
Okay,
yeah I
very
could
nice.
okay yeah, of course I did. I have written a detailed report. If you want, I can show it to you later.
No,
There is
it's
more
fine.
explored data analysis,
Yeah.
more modeling, and so on. So I think the score is not really high because
Not high, but
vocabulary is
it works.
very big for English, and a lot of people, mainly youngsters, are writing words incorrectly. So that makes for model difficulties to make correct predictions. And finally, we have few examples of how model works in real life. So the first sentence is we have I love this area, and it is classified to positive class with 76% of probability. Second sentence is I hate case area. It is classified to the negative class with 89% of probability. For now, it's working kinda correctly. The third sentence is a bit more complex. The sun is shining bright and the flowers are blooming in the beautiful garden. It is classified to the positive class with 91% of probability. And the last sentence is no one will come after me. So I have a question for you. To which class would you classify this sentence? No one will come. Neutral?
Positive.
Positive? No one will come after me. You say positive.
No, neuter, a little. Let's say negative, but more neuter.
Mm-hmm.
Okay.
What about Ebru?
I catch it. Which one?
No one will come after.
Is it
Ah,
Is it positive sentence or negative?
negative.
And I can.
I wanna say positive.
Yes. So model is not sure itself. It says negative, but only probability is only 52%. Yes.
you have to know.
Yes.
words.
He doesn't know words, and maybe we need more context, because also Bruce said negative, Hakan said positive. So even when the human is determining if it is positive or negative, we are not sure which is it. And model as well, he says like it's 50-50. Yeah, I hadn't had to, unfortunately, in my data neutral class, so it is not classifying to neutral. I tried adding myself that, but it hasn't worked. So that's for me all.
Thank you. It's very nice. Maybe in future you may add an aim to this data set in the beginning, like a research question. Why are you doing this positive negative classification?
Mm-hmm.
If you put that one, it will be a paper, for example,
Okay.
for future. The aim, and you can then comment about your results depending to your aim. Then
Okay.
it will be, but it's a perfect working time here. You do so good things here.
Mm-hmm.
You didn't know Python before that much. You
That
told
much
me
not,
that,
but,
you told me
yeah,
that you're
we-
just a beginning programmer.
Yeah,
Isn't
we
it?
those data cleaning libraries I had to learn from
You
zero.
Yeah.
Yeah.
Okay, very, very nice. Not only library, but also the classification models, you know, pre-processing,
Yes.
classification models, all of them. And you do natural language processing.
Mm-hmm.
And maybe for future you can do natural language processing, that pre-processing part in your natural language.
Oh, in Lithuania.
Yeah.
Yeah, it is possible with the that modeling to do in any
Yeah,
language.
and you can put a name and you can do the model.
Mhm.
Maybe you can write an interface also. It is just a library.
Yes,
There are
yes,
so
yes.
many libraries in Python. Then you will have a research.
Okay.
Yeah.
Thank you.
Okay, very nice. Thank you so much.
Okay. So hi, hello. My name is Rubina, and my internship task is about my Spotify data. And my aim is to create recommendations for the user, and so that's it. So as I said, I'm working with my Spotify data. So I asked them to gather all the past years' information about me and my account, and they send me all these files, but I just work with this one because it has all the information I need. And then I divided that file into 3 more data files. So the first one contains information about the time that I listen to music and the duration of the song. And you can see the 0 in the MS plate, so that means I skipped that song. And then the second data file contains its song, its artist, and its attributes such as loudness, danceability, energy, and etc. And the third one data file, its song, its artist, and its lyrics. And some songs does not contain lyrics at all, or the algorithm didn't find the song. So didn't find the lyrics.
Okay.
But that's not very common. So my goals is, I have a couple of goals to do some analysis on song attributes, find out the trends in the mood over the past months, then using NLP find out what are the most common words that appear in the songs, and thus they have the hypothesis that some word just attracts more the user than the others, and find out the most common time of the day when I listen to music in order to suggest some recommendations at the most suitable time. Yeah. So, first of all, about listening time, I sum up all the past years' listening time, and it appears then that I commonly listen to music on the Tuesdays, and in the past year I listened about 70 hours of music. This is the same graphic, just divided by weekdays and hours. And as you can see, I listen mostly Tuesdays at 10 a.m. and on Sundays 11 p.m. Yep. So this information will be needed later. Then I did analysis on some song attributes for the past 2 months. So the blue line is energy, song is energy, and orange line is song's balance, and they're changing similarly, but the averages of those two attributes differ. The average of energy is about 0.6, and the average of the balance is about 0.4. So this is needed to create recommendations and suggest some new, not known songs for the user with those attributes and their values. Also, I did some interactive graph about my songs. Each dot represents the song, and you can move your mouse on dot and the song title and its artist appears. And x-axis we have statistic about how calm the song is, and on y-axis we have how metal the song is. So if the song appears in this quadrant, it means that it's a very calm song, and if the song appears in this quadrant, it means it's a very metal song. So yeah, and then I divided that same graphic into 10 clusters. I did with the machine learning method KAUNAS, and then I created 10 playlists from those groups, and these are most successful, I say. The first playlist is more like a fun dancing playlist, then the second one is very sad songs, and the third one is very metal songs, and other playlists are just a mix between those three. Yeah, and I did some research on the languages that I listen to. So in the first place we have English language, in the second place we have Lithuanian languages, and other languages appears only for one or a couple of songs. Maybe it's because of Eurovision. If you don't know what Eurovision is, I can say later.
We know.
You don't?
We know.
Oh, okay then. Okay, yeah, okay. And I did some word clouds on the English and Lithuanian language. So in English language we have know, love, like, and in Lithuanian language we have words like noriu, which means I want, nežinau, this word, which means I don't know, and this word niekas, which means nothing, so kind of depressing. And I did the same thing on the artists. So I gather top 20 artists that I listen mostly, and we have some pop artists like Lana Del Rey and some metal artists, and I did the word cloud thing on them. And as you can see, like Lana Del Rey has a very romantic word love, and System of Down has the most diverse vocabulary because they don't have the most common word. So it's like the end of my presentation, and I'm still working on a couple of things, such as Lithuanian artist songs and their sentiment analysis and word plotting, and I'm still working on getting access to all Spotify data in order to create a new not known song playlist of not known songs for the user. So this part is very hard. So I'm still working on that. So
Thank you. Thank you. It is an amazing topic. Do you know, we also work in this topic. We have a happy crowd research group, and we work in the field of happiness, actually. After this sentimental analysis, you can work in the dimension of emotions, because emotion in literature, emotions has so many clusters, or you can also visualize emotions in three clusters. For example, valence, arousal, that type. Not love, sadness. It is valence, a pleasant topic. This valence scores shows the being pleasant and happiness of the words. So you can measure that happiness depending on these scores, like a new dictionary, effective words of English, actually. And this topic, in this topic, there is a research group very famous in USA that they dots, and I didn't remember the names of the researchers, but they have the hedonometer, and they already measured nearly 15 years ago. They already measured, for example, Michael Jackson's songs, depending on the natural language processing, like what you do. You didn't measure the music data, you measure the text data, actually. Yeah, this is what we do also. And there's a hedonometer, you can check that one. And they visualize the songs also. And it is a very nice topic because maybe you can, what we aim is, maybe you can maximize someone's aims depending on music, why not? By the words and the rhythm, maybe. The aim is that in this topic, actually. Maybe in your language.
Yeah, I'm still working on my language.
Maybe in future we can work together. More than here, yeah. Okay, thank you so much. Now we see two nice presentations, so it is harder for you, and also they do good, and also we are very curious about what you do here.
My friends say that
And
this might be the hardest one.
Okay, you're the hardest.
Yes.
Turkish. Do you know Turkish?
Very little.
Okay, very nice. But you can analyze it well.
So my task was with a given data set of Turkish folk songs, do exploratory data analysis and try to create a classifier for them. The aim would be like, the classifier could help archaeologists to determine the new songs from where it came. So that would be like the impact. And I took the data from Kaggle. It wasn't worked on, but it was prepared. So it has only 4 columns: song name, region, info, song content. The main ones are region and song content because info has nothing useful. It repeats the region and has a singer, but a writer. It doesn't give any additional information. And this one column I left for further analysis, but I didn't also thought it was very important. Also, there was a disclaimer of missing songs, lyrics, or incorrect lyrics. I couldn't check it because I don't even know. I am not proficient in Turkish, so I take it for granted that everything, most of the data is fine. So there was some problematic data in regions. So there was misspelled regions like Azerbaijan and Azerbaijan. I know that it's another country, but in this data set there was some regions around Turkey that are not for Turkey. And also there was multiple regions. So I cleaned them pretty well, because the misspelled regions were only like 6 or 7 instances, and all multiple regions were separated into 2, and the songs were copied. So looking into region distribution, here you can see there was 96 different regions. The Sivas regions had the most songs, more than 300, and the drop-off is very impactful, very steep. The red line is the average, and the blue line is the median, which I used later. There were a lot of regions with 1 or 5 songs. It's for classified it might have been impactful, and it couldn't classify it correctly. Also Kayseri, I didn't remember where, but it was somewhere above the blue line. I also did the same graphical interpretation, but on the map. So blue are those regions that didn't have any songs, and all other are colored in by the corresponding color map. As you can see, the most of the songs are from this part of Turkey. And with different coloring, it's the same map, the same data, but colors are dependent on the average. So red regions have a number of songs higher than the average. So as you can see, the highest regions are here and others. And blue colors below. Also the gray is where no data was given. So like first data analysis was this word count per song. As you can see, mostly songs have about 50, 60 songs. There were 2 outliers with more than 600 songs and more than 300 songs, but mostly it seems normal distribution. I haven't done any tests to check it, but I'm thinking of doing it next week. I needed an extra step with count vectorizer, which just represents the sentence in a number in a vector. With this, I could more easily do some further analysis about song titles and song words. Nowadays, songs usually the title is part of song lyrics, so I thought to check that if this is true here. So as you can see, there were a lot of zero repetitions, zero non-repetitions. I'm sorry. That means that every word from some title repeated in the lyrics, and there were 1 non-repetition, 2, 3, and 4. So mostly from 1 to 4 words went into the song lyrics. And this is the same graph, but in percentage-wise. So the percentage of the title that didn't appear in song lyrics. It might be easier to see if I remove the zeros. It's I would say way cleaner. So mostly 1 word from song title and song lyric didn't appear in 500 times. But looking at percentage-wise, usually about less than 1/3 of song's title didn't appear.
The difference is the words? No, the 1, 2, 3, the difference?
1 means that 1 word from song title didn't appear in the lyrics.
Okay.
Yeah, so 2 means 2 words, 2, 3, and etc.
Okay.
Percentage means the part of the title. So if 50% means that 50% of the title words didn't appear. So usually it was about less than 1/3. So for further analysis, I didn't include some title because I thought that it would give meaningful information with only 1 or 2 words.
Okay.
So next I did the same word clouds for every region. Here is Kayseri, most important for us. But as you can see, there are a lot of command repetitions in every region and other words. So I introduced them into stop words and removed them. It's way more diverse, I would say now, but in Kayseri is still a man left but with double M. I believe it. I don't know what's the difference with 1 M.
There are so many meanings of aman. There may be. Actually, it's also a stopper, but it is hard to work in folk song data because which lemmatization or stemming, which dictionary did you use for the words to reduce the words?
The inbuilt libraries like analitiği didn't have stock words for
Yeah.
Turkish language,
Okay,
so I
that's
had to
why-
download it from
Yeah.
also Kaggle. So
Even one word has so many meanings in Turkish, depending to the region.
Yeah.
So,
that's where my incompetence can show up. But one interesting finding, all the region sings a lot about Allah.
but you also delayed the güzel word. The güzel means beautiful. In previous one
I can
has.
say.
Did
That
you get
word
it?
might get included into stop words because I deleted the words that repeated in more than half of the regions. So
Okay.
it might have appeared in 50
Because
regions and was
Güzel
above
is a
average.
positive word and a very
Yeah, Güzel, beautiful.
and the number of the songs are also, you know,
Mhm.
in Kayseri, not that much song as you show us
Mhm.
than like Erzurum, fewer songs we had. So you do a smaller data.
Yeah.
Okay, very nice. Oy oy.
So more into numbers, this is the graph of number of unique words. So of course C was with the most number, the most songs had the most unique words. The same could be said about total words, but the difference is 6,000 unique words and about 18,000 total words, more than 3 times. And the last one, it's very hard to pronounce it, but it's the percentage of unique words used. So how many of these words were, what kind of part, what part of this these words make.
Okay.
Yeah, it's a bit of a tongue twister, and the red lines in all 3 graphs represent the average. So here the top one was Orta Tonstar, I believe, if I correctly pronounce. So it almost used all of the unique words. I believe it had only one song. So for that, every word was unique, and that percentage was high.
Those words are the same. Aman, but the region is different.
Mm-hmm.
It depends on which library and which dictionary you use
Mhm.
for these ones. Maybe you can form your Turkish dictionary, your own.
Yeah, so nextly I did a little bit of sentiment analysis.
Okay.
The library textbook didn't support Turkish language, so I had to do a workaround to use a translator to translate into English and then do sentiment analysis. So this result is not 100% correct, I would say.
Okay.
As you can see, there might be a lot of bad translations that corresponded to all zeros because sentiment analysis doesn't find any understandable words, it sets it to zeros. So you can see your zone was mostly about negative thoughts.
Giresun.
Yeah, but most of the regions were in this like little clouds, a little bit positive, but mostly opinionated. And the red dots mean that there was below average songs and below above average. I'd stick to that theme. So the next part of my major part was the classification part, and I used 6 different, I experimented with 6 different algorithms. So firstly, it was the first thing that came to my mind was K nearest neighbors. Nextly was, as Thomas used naive bias, the probabilistic approach more. Thirdly, I used random forest, a big class of decision trees, but each one of it is randomly generated. Also ADA boost or XG boost, this is something similar to random forests, but each tree is smaller and has its own weight. The fifth one was neural network, the machine's way of trying to mimic our brain with neuron layers. And lastly, voting classifier that combines all of the classifiers and makes predictions on voting software or hardware. So before that, I needed to make some more preparations. For this, I used regions where I corrected the misspelled regions, but I didn't separate the multiple regions.
Okay.
Because it will be another task to classify to multiple classes. I wasn't too experienced in that, but there are only like one song that's for each region, so it's like also an outlier. So I used also every region that was above the median, I used in my classification data. I missed one thing. As you can see, the class imbalance is very big. CLOS has 300 and my lowest has about 20 songs, so it's a big of imbalance, and I needed to do something with that. So I used some synthetic data aggregation, data manipulation. I used techniques mode plus command that oversamples and undersamples the data. So you can see here a minority of blue dots, and after the technique it's something similar with the orange dots. I also needed to encode my regions into numbers, so it was just putting on the label. I also used a different kind of vectorizer, not count vectorizer, but TF-IDF vectorizer, which checks, also looks into the importance of the word in the text. And lastly, I introduced n-grams. Mostly, the best result I got.
2 grams.
Yeah, this examples with 2 grams, but I
What
tried
do you use?
with
Okay.
from the range to 1 to 5.
Okay.
But the best result was with bigrams.
Okay. Very good.
So after all that preparation, we can see that classes are now in numbers and the distribution is pretty equal. So the best result was gotten with neural network. The ideal result would be if every value would be in this diagonal, but as you can see, there were some 2s, 1s here, but it should be all 0s for the ideal moment. The most like eye-catching is these 10 and 9s. So I had problems with the most biggest regions. Sivas, Erzurum, Erzincan.
Yeah.
So by looking to numbers, every class has about 197%, but those are the oversampled ones, I would say. The biggest ones like Erzincan have 85%, which is pretty good. Erzurum below the 80% line, but still just every fourth would be misclassified, I would say. And the biggest headache for me was Sivas. That's the best result I managed to get. Today I tried another approach and got 60% with other classifier, but still it's hard to get into 70s, 80s with this region. But overall it's 97%. I would say other regions below that average. So for further, I would think I need to do more data gathering to address the class imbalance and as the disclaimer said, invalidate or misspell data. Also, I would need to use better computational resources because that neural network took me 3 hours. And every time I want to make a little change.
Properties?
Yeah, I would say decent, but for better classification algorithms, the more complex ones, more deep ones, and especially for parameter tuning, I wanted to tune XG boost. One training session would take about an hour, and it calculated with my parameters I would need about 1,600 sessions, so 1,600 hours. So that's a little limitation for me. Also, that corresponds with deeper and more complex models. Lastly, as I said I wasn't an expert in Turkish language, I would need to cooperate with experts in Turkish language, especially ethnic ones. So
Thank
that's
you.
our big presentation.
Yeah, it was amazing. Thank you so much for this one. I'm very happy that my students, my Management Information Systems Master Program students will also watch. Today they couldn't attend, but we will, for sure, I will make them listen this presentation because you do so good things in short time. This is what we do in maybe a year time.
Yes, that's why for me it is very hard to clean that big data sets in short of period of time.
It is very nice, and I like the way of presentation. Please call us, call me, write me if you need anything from here, or if your department wants to do agreement with